Okay, so today we are going to start with another experimental topic which is related to the interference that is called diffraction grating. Previously, we discussed about Young double slit experiment, and that experiment is for the interference of the light rays coming from a source of light through two different slits. And today we are going to talk about diffraction grating. So basically, in diffraction grating, or basically why there is a need for another experiment for interference, because we already discussed interference in young double slit experiment. So why we need another experiment for interference? So basically there are some problems with young double slit experiment. So if we talk about those problems with double slit. The first problem is that the spot we got on the screen are of very low intensity, जो उनकी ब्राइटनेस या डार्कनेस हम कह सकते हैं, जो स्क्रीन पर आपको मिल रही थी स्पॉट्स की, वो बहुत कम थी। तो आइडेंटिफाई करना जो है वो डिफिकल्ट होता है। सो दिस इज द फर्स्ट प्रॉब्लम विद डबल स्लिट एक्सपेरिमेंट। सेकंड, देयर इज वेरी स्मॉल गैप बिटवीन स्पॉट्स। डार्क और ब्राइट फ्रिंजेस में गैप बहुत कम होने की वजह से अगेन काउंटिंग करना थोड़ा सा प्रॉब्लम होगा। सो दिस इज द सेकंड प्रॉब्लम विद यंग डबल स्लिट एक्सपेरिमेंट। So these are the two problems. That's why we used to perform, or we use another different experiment for the interference. Okay. So basically in diffraction grating is a different setup as compared to young double slit experiment. In this diffraction grating setup, let's suppose if we take a piece of plastic or glass, and in this piece of plastic or glass, there are like thousand of lines per centimeter or per millimeter marked on it. So basically, if we take a simple plastic or a glass piece of few centimeter, like 1 by 2 centimeter, 2 by 3 centimeter, very small piece of plastic or glass, and when we mark so many lines on it, और ये लाइंस हम मैनुअली मार्क नहीं कर सकते, दीज लाइंस आर ऑलरेडी मार्क्ड विद द हेल्प ऑफ सम डिवाइस, डिजिटल डिवाइस, because there are so many lines in a few centimeter, like there are 100 lines in 1 centimeter, 200 lines per millimeter. So there are so many lines in very small distance, so it is not possible manually. And we also studied the concept of diffraction in IGCSE, that diffraction takes place through the corner, through the edges. So that's why we have to mark so many lines, so light can easily collide, or it can be easily strike back from any obstacle or any corner. So this is the concept of diffraction grating. And in diffraction grating, this material is called grating element. So this grating element comprises of hundreds of slits per centimeter, so that more light can pass.
Sir, sorry to interrupt, but where we use this grating element?
Basically, there is a device which is called spectrometer. In a spectrometer, we use this diffraction grating. Right now, we are writing some description about it. We will also draw diagram and also discuss how it actually works. So then you will get idea that why we are using this diffraction grating element and how it actually works. And with the help of diffraction grating, you can practically got the idea of the concept of interference that we studied theoretically. So you can practically perform this experiment of interference with the help of diffraction grating and Young double slit experiment. So basically, you can see there are 100 of lines in single centimeter. So it is very easy for light that can easily pass through these lines, and it will produce more bright spot on the screen. And again, the previous two terms remains the same. That is for maxima and minima. Maxima again represents constructive interference. Minima represents destructive interference, just like in Young double slit experiment. Maxima gives bright fringes and dark fringes are due to minima or destructive interference. This is due to constructive interference. This is due to destructive interference. Okay. So basically it works like this. Let's suppose you place this plastic piece on a table, right? And there is a light source coming towards this plastic piece or diffraction grating element. So let's suppose if we place grating element over here, this is our grating element. And when light pass through it, let's suppose light is coming from a single source. It strikes over here. So when light strikes this grating element, so due to so many lines in single centimeter, there is a process or there is a concept of diffraction takes place. If you remember in IGCSE, we studied that when water waves or rays pass through the gap, so it starts to change its shape. And there are two different shapes that we discuss, semicircular shape and slightly curved shape. So due to the same concept of diffraction we used over here, because there are so many lines and there is more possibility for diffraction takes place over here. So light splits into different direction with different angle. Let's suppose this is the center, and from this center line, you will get light first of all in the center. You will get a bright fringe in the center. Then you will get another bright fringe after some distance. Then another bright fringe after some more distance. In the same way, you will get bright fringes on the other side, like this, at short angle. Then angle increases. Then further angle more increases. So in this way, we will get different positions of bright fringes, and we can easily mark them. This is the central one. N is equals to 0, central maxima. Then we will get N is equals to 1. This will be N is equals to 2. In the same way, on the other side, this will be N is equals to 1, N is equals to 2, N is equals to 3. So from the center, if you are moving towards one side, so you will count 1, 2, 3. And if you are moving on the other side, so again you can count 1, 2, 3. So you can split bright fringes towards right or left. तो सेंटर से आप अगर राइट साइड पे काउंट कर रहे हो तो आप उन्हें राइट साइड ब्राइट फ्रिंजेस काउंट कर सकते हो, और अगर आप लेफ्ट साइड पे काउंट कर रहे हो तो लेफ्ट के अपने ब्राइट फ्रिंजेस 1, 2, 3 काउंटिंग होगी. So in this way you will get bright fringes on the screen. And as we already know, the central one is called central maxima, 0th order. This is central maxima. Then we have first order, second order maxima. This is first order. In the same way, this is second order maxima. On the other side, you will also get first order maxima, second order maxima, third order maxima. And there is a gap between these maxima, right? Let's suppose if we consider any gap, like between N1 and N2, there is a gap. So this gap represents minima. It means destructive interference, dark fringes. So in the same way between N0, N1, N2, N3, this is also minima. In the same way on the other side, you will get minima also. This is minima. This is minima. And one more important thing, in this diffraction grating, we also use angle, theta. So how to measure that theta? So basically, we start from the center, from central maxima. Let's suppose if you want to measure the angle for the first order, so you have to measure from the center. This is theta 1. And if we want to measure angle for the second maxima, so you will measure like this. This will be theta 2. And the same way, the third one, theta 3. So in this diffraction grating experiment, angle is also important, theta is also important. So we are going to use theta also in this topic. So in this way, you will get different maxima, different minima on both sides, like towards right hand side, towards left hand side. And again, we are using a monochromatic light. This is monochromatic light. Okay, so this is the experiment. This is the idea that why and how we use this diffraction grating to perform the experiment of interference. And we got dark and bright fringes on the screen. Now we have to discuss about the formula, that what is the formula for diffraction grating and how we use that formula also. So the formula for diffraction grating is n lambda is equals to d sine theta. N represents order, lambda definitely represents wavelength, and d represents slit separation. And it is the angle between 0 and any specific order, first, second, third, whatever we are calculating. Okay, so we discussed the formula and lambda is equals to d sine theta. And in this formula, you observe one thing, that d represents slit separation length of one line. So we know that there are hundred or thousands of line in a single slit, or we can say in single grating element, but we only need to find out the length of one single line, not all lines, right? So this is one more important thing that we have to know in this formula. And theta is like angle between angle we can measure from the central bright fringe to the specific bright fringe that we are going to find out. Let's suppose in your question, you will get like this. In example, that monochromatic light is incident normally on diffraction grating having 4000 lines per centimeter. So in your question, you will get number of lines like this: 1000 lines per centimeter, 200 lines per millimeter. So in this way, you will get the values. So what we have to do? So the important thing we are going to discuss over here, to how to find out the value of D, because this is a new quantity that we never discussed before in young double slit experiment. So basically, if you want to find out the actual value of D, so calculation for finding D, So we have 4,000 lines in 1 centimeter. And according to SI unit, if we convert centimeter into meter, so this 4,000 lines is actually equals to 0.01 meter. So basically in 0.01 meter, there are 4,000 lines. To find out the value of D, you have to write down the value in meters divided by the number of lines. So you will get the answer in. So basically, single line covers 2.5 exponent minus 6 meters, right? So this is the separation of a single line, this value of D. Okay. So this is the calculation part related to the value of D, because value of D is a slightly different idea from the normal values, because all other values are simple. We can easily identify them, but the value of D is slightly different. So that's why we have to find out them. So this is the idea of diffraction grating. And let's suppose if we consider the questions from the diffraction grating. So let's see.
Wait, sir, can you explain the calculation for finding D again?
Okay, so to find out the value of D, you will get in questions like this. There are some specific lines will be given in millimeter or in centimeter, right? So let's suppose if you are given unit of centimeter, so you can convert centimeter into meter by dividing by 100. And let's suppose if you got millimeter in your question, so you can convert into meter by dividing by 1,000 or writing by -3, 10 to the power -3. So in the same way, there is one example. If we got 4,000 lines per centimeter, so it means there are 4,000 lines in 1 centimeter, and we convert centimeters into meter. It means there are 4,000 lines in 0.01 meter, because we convert centimeter into the meter SI unit. Now we just simply need to find out the length of one line, because D represents,
Ah, okay, okay.
yes, it represents length of one line. So that's why we divide 0.01 by 4,000. So you will get the length of a single line, which is 2.5 exponent minus 6 in this question. And if we find out the question, okay, this is for double slit. This is intensity. Okay, there is no question in May, June 23. Okay, this part is related to diffraction grating. So let's try this one.